Hi children, welcome. Welcome to another chemistry class. In this session, we are discussing a few very important questions from the chapter 2, that is structure of atom, atomic structure, most probable, very important questions from the chapter we are going to discuss in this session. Hope you enjoy it. Can we start? Ready? Yes. We have the first question in the board. Correct order of increasing energy of the listed orbitals in the atom titanium. You know titanium. Atomic number 22 coming after scandium in the first transition series. All of you know the answer, how it is coming. Atomic number 22 will be configured as D2S2. The configuration end up with a noble gas core 3D2 4S2. That is the electronic configuration. From the atomic number itself, you can write that configuration. Atomic number, you see that 22. It will be D2S2. Scandium 21. It will be D2S1. Iron 26. It will be D6S2. Like that. You know that. So here asked is the order of filling of atomic orbitals. That too is a very simple point which all of you know. This is the order. Second choice. It is 3s, 3p, 4s, 3d. Off-bow principle, fundamental question, right? 3s, 3p, 4s, 3d. That is the order. So after 4s, 3d will be filled. After 4s, 3d will be filled. Next question. Wrong statement. Asked for wrong statement. De Broglie wavelength given, lambda equal to h by mv, all of you know. Uncertainty principle, delta E delta T greater than or equal to h by 4 pi. Uncertainty principle you have learned, right? The product of uncertainty in momentum and position is greater than or equal to h by 4 pi. There is another version for uncertainty principle, energy versus time. So don't think that it's a wrong statement. This is true statement. This is true, and second one is also true. Half-filled and fully filled orbitals have greater stability due to greater exchange energy. NCERT question. NCERT statement. The energy of 2s orbital is less than 2p in case of hydrogen. You have learned for hydrogen like atoms, energy is decided by n value only. Energy of atomic orbital decided by n value only. So what is the order of energy for atomic orbitals for hydrogen? 1s, 2s equal to 2p, 3s equal to 3p equal to 3d, goes like that. So quite naturally this statement is wrong. This is a wrong statement and that is the correct answer. So for multi-electron atoms, the energy of orbital decided by n plus L value. For hydrogen atom, it is decided by n value alone. You have been taught in the class and hence the answer. And this is regarding uncertainty principle written in the form of energy, uncertainty in energy. There must be uncertainty in delta T during which measurement is made. If a state is measured to have energy E with uncertainty delta E, there must be an uncertainty delta T in the time during which measurement is made. If you might have learned that. If you haven't seen, take it as an additional point of information. Uncertainty principle, usually we write like, what is the format? Delta X into delta P greater than or equal to h by 4 pi. It can be understood in another way also. Okay, next. The correct option for, again, energy of the orbitals. Off-bow principle, once again. Aufbau principle, once again, you know how to find energy order. You go for finding n plus L value. It is written in the n plus L value order. When the n plus L value coming same, you will go for lower n value first filled. Right? So lower the n value, lower the energy. So it is in the order of n plus L value. Lower the n plus L value, lower the energy. Suppose two orbital with the same n plus L value, lower the n value, lower the energy. Higher the n value, higher the energy. Like that. So the order, you know, it is fourth choice. It is 4D, 5P, 6P, 5F. So 4D it is 4 plus 2, that is 6, 5P, that is 5 plus 1. So this is 6, this is also 6. So this will be lower energy. 6P, 6 plus 1, 7, 5F, 5 plus 3, 8. So there is no confusion here. Here it will be 4D less than 5P. N plus L rule, right? Also known as Clenchovsky rule, Aufbau principle, N plus L rule, right? അടുത്തത് visible spectrum fall in Balmer series, visible spectrum fall in Balmer series, Lyman series, UV region, Balmer series, visible spectrum. Next, wrong statement. We want to get the wrong statement. Electronic configuration of nitrogen atom, that itself is wrong. You understand this is violating Hund's rule, where the electrons are parallel spin required. See, the orbitals, degenerate orbitals should be half occupied. The degenerate orbitals should be singly occupied with electrons of parallel spinning, isn't it? It is given opposite spinning. That is the wrong statement, and that is the correct answer. You see the other choices. 3 quantum number, while electron in the 4th quantum number. Orbitals are designated by principal quantum number, azimuthal quantum number, magnetic quantum number. Angular momentum of s orbital 0. Value of m for dz square is 0. Value of m for dz square orbital is 0, as the orbitals are coming through the internuclear axis. Orbital coming through the internuclear axis, the magnetic quantum number taken as 0. For f orbital, I think you have learnt fz cube will have magnetic quantum number 0, right? So pz we can take magnetic quantum number 0 like that. Okay, next. Electron density along the axis. Electron density along the axis, dz square, dx square minus y square, dz square, dx square minus y square, while dxy, dyz, dxz bisecting the axis, right? Go through the diagrammatic representation, orbital angular momentum diagram for, the d orbitals. How many electrons fit in? N equal to 3, L equal to 1. N equal to 3, L equal to 1 means 3p orbital. 3p orbital, p orbital can fill 6 electrons, as there are 3 orbitals. P orbital contain px, py, pz. Each orbital 2 electron. So it is 6 electron. Next. 4s electron, 3d electron. 4s electron, 3d electron. You know how to find the orbital angular momentum. Root of L into L plus 1h by 2 pi. For s orbital, L is equal to 0. Therefore, s orbital angular momentum is 0. This is out, this is out, this or this. You can evaluate easily. Answer is option D. How to get that? How to get that option D? You see, L equal to 0. L equal to 0 for s orbital. Therefore, it is 0. While d orbital, L equal to 2. So it is root of L into L plus 1h by 2 pi. That is root of 2 into 2 plus 1, you will get root 6h by 2 pi. Option D is the correct answer. Okay, right. Next one. A graph is plotted between maximum kinetic energy of ejected electron and frequency of incident light. Which of the following plot is correct? Energy versus frequency. Kinetic energy versus frequency. Kinetic energy half mv square is equal to h nu minus h nu 0. Half mv square is equal to h nu minus h nu 0. So how is going to happen? Half mv square, that is kinetic energy, E is equal to h nu minus h nu 0. This is taken along the y-axis and this is taken along the x-axis. So this will be slope of the line. Slope of the line is positive. Slope of the line is positive means this graph is out. Now the y-intercept, this is the y-intercept C and that is negative. Y-intercept negative means here y-intercept is 0, out. Here y-intercept is positive, out. And the answer is option C, where the y-intercept is coming negative. Y-intercept coming negative. So 2 point, positive slope and y-intercept negative. Enough. Okay. Yes. Option C. Sorry. Next question. Uncertainty in position and momentum of particle like electron are equal. Uncertainty in position and momentum are equal. Uncertainty in velocity, that is asked. So it is given delta x is equal to delta p, that is equal to m delta v. So delta x is equal to m delta v, asking for uncertainty in velocity. How to find out? You see, delta x is equal to m delta v. So you can write delta p square, that is delta x into delta p. So this is equal to this. So it is delta p square equal to h by 4 pi. That is delta p is equal to root h by 4 pi. That is 1 by 2 root h by pi. Now delta p and it is m delta v. M delta v is equal to half root h by 4 pi. Therefore delta v will be 1 by 2m. So it is 1 by 2m root h by pi. 1 by 2m root h by pi. Option B is the correct answer. Isn't it? Simple question. Next one. Total number of spectral lines theoretically possible in the de-excitation of electron from n equal to 6th level. N equal to 6th level. You know how to find the total number of spectral lines. N into n minus 1 by 2. 6 into 6 minus 1 by 2. 6 into 5. 30 by 2. 15. 15. So this equation taught in the classes. N into n minus 1 by 2. Right? Suppose it is n2 to n1, you know what is the formula. n2 minus n1 into n2 minus n1 by 1, n1 plus 1 by 2. Right? Next. So which answer? Option D, 15. The ratio of difference in energy between first and second to that between second and third. First and second to that between second and third. That is what asked. Difference in energy between first and second, second and third. That is E1 minus E2 by E2 minus E3. This is what asked you to find out. And you know En is equal to E1 into Z square by N square. You have learnt. We are asking for what? Bohr orbit. Asking for Bohr orbit. So he said you can take it as any particular atom. So the value will be E1 minus E1 by 4. You see, E2 is equal to, what is E2? E2 is equal to E1 by 2 square. So it is E1, E2, E1 by 2 square divided by E1 by 2 square, that is E1 by 4, minus E1 by 3 square, that is E1 by 9. So what do you get? 1 minus 1 by 4 by 1 by 4 minus 1 by 9. That is the answer. 1 minus 1 by 4 by 1 by 4 minus 1 by 9 will give you the answer, and that will take you to option 27 by 5. You will get 27 by 5. Which choice? Option C, 27 by 5. So if you know the relation, directly you can approach to that final result. 1 minus 1 by 4 by 1 by 4 minus 1 by 9. Enough. So it is 27 by 5. It is E1, E2 difference, E2, E3 difference. Next. Ratio of radii of first 3 Bohr orbit of hydrogen atom. First 3 Bohr orbit of hydrogen atom. You know Rn is equal to A0 n square by Z. We are talking about hydrogen. So Z is equal to 1. So what is the result? R1, R2, R3 is asked to find out. R1, R2, R3. So it will be R1 is A0 by, sorry, it is A0 into n square. It is 2 square and A0 into 3 square. 3 square. So what is the ratio? A0, A04, A09. So it is 149 option B. 149 option B, as Rn is directly proportional to n square. So 1 square, 2 square, 3 square. 149 over. Next. Energy of an electron in the second Bohr orbit of hydrogen atom minus 3.41 electron volt. Energy of electron in the second Bohr orbit of helium plus ion will be, we want to find out E2 for helium plus. We want to find out E2 for helium plus. E2 for helium plus. How is that? It is E1 for hydrogen into Z square by N square. That is E1 for hydrogen into atomic number of helium. It is 2 square divided by 2 square. So it is E1 for hydrogen. E1 for hydrogen. E1 for hydrogen, you know the value. You need not find out actually. You need not find out actually. It is B. E1 for hydrogen is minus 13.64 electron volt. You know the data. It is B. So E2 for hydrogen. E2 for hydrogen is E1 for hydrogen by 2 square. That is E1 by 4. Therefore, E1 is equal to 4 E2. So need not go for that. You know the E1 for hydrogen, that is first orbit energy for hydrogen minus 13.6. You know that. Next. And also keep it in mind, energy of energy of first orbit of hydrogen is equal to energy of second orbit of helium plus is equal to energy of third orbit of lithium 2 plus is equal to energy of fourth orbit of beryllium 3 plus. Keep it in mind. Next. The quantum number is correct for an electron in 4f orbital. 4f orbital. 4f orbital, n is equal to 4. Now, f orbital, you know, L is equal to 3. So, this is out. This is out. L is equal to 3 required. For L is equal to 3, M can be plus 1. M cannot be plus 4. So, this is out. Option A is correct. N is equal to 4, L is equal to 3. M value, it can be minus 3 to plus 3. And M value either plus half or minus half. Next. Option A. For hydrogen atom, energy level vary in the order. Recently we have discussed. Option C. It is decided by n value only. It is decided by n value only. Energy of atomic orbital of hydrogen decided by n value alone. Next. Maximum number of electrons in a subshell is given by the expression. Maximum number of electrons in a subshell is given by the expression 2 into 2l plus 1, 2 into 2l plus 1, 4l plus 2. Number of orbitals in a subshell 2l plus 1. Number of electrons in a subshell 2 into 2l plus 1, 4l plus 2. Next. Ratio of energy of a proton of wavelength 2000 Armstrong to that of wavelength 4000 Armstrong is ratio of energy of a photon. Energy versus wavelength. What is the relation? Energy versus wavelength. Energy is equal to h nu is equal to hc by lambda. That means energy is inversely related to lambda. So E1 by E2 is equal to lambda 2 by lambda 1. Lambda 2 divided by lambda 1, 4000 by 2000, 2 is to 1. Option C, 2 is to 1. Right? Next. A 100-watt bulb emits a monochromatic light of wavelength 400 nanometer. Number of photons emitted per second. Number of photons emitted per second. You know the relation? E is equal to nh nu, where n is the number of photons. E is equal to nh nu, where n is the number of photons. Right? Here given is wavelength. So it is n into hc by lambda. You know this value, this value, this value given, and this value given. 100-watt bulb. So energy available. Hc you know, lambda given. Find out the number of photons. This is asked to find out. Find out the number of photon. What will be the value? N is equal to E into lambda by hc. N is equal to E into lambda by hc. E into lambda by hc. So all the data given, E value, lambda value, H value, C value, you can get your answer 2.01 into 10 power 20, option A as the correct answer. And simple calculation also. Okay. A typical question. Next. Kinetic energy of photoelectrons ejected from a metal is X when it is irradiated with a radiation having frequency twice the threshold frequency. If frequency of incident radiation is again doubled, the kinetic energy of photoelectron would be. So what will happen? You are doubling the frequency. You are doubling the frequency. What will happen to kinetic energy? That is the question. So kinetic energy is equal to h nu minus h nu 0. So this is equal to h when h 2 nu 0 is equal minus h nu 0. You see, this is x when irradiated with the radiation having frequency twice the threshold frequency. So this is equal to twice this, isn't it? And now, what is the frequency? So what is the kinetic energy when the radiation frequency is again doubled? So it becomes h double of this 4 nu 0 minus h nu 0. That is the question. That is the question. Now take the ratio and find out what happens. H nu 0 cancels. H, see, x by the required value. X by the required value is equal to h nu 0. Take out and cancels and you get 2 minus 1. 2 minus 1. 2 minus 1 divided by 4 minus 1. So it will be 1 by 3. So x by the required value is equal to 1 by 3. So it is 3x. Option C. 3x. Option C. A beautiful question. So we are doubling the frequency. Then the kinetic energy becomes 3 times. 3x. So case 1, it is nu 1 is equal to 2 times nu 0. Case 2, nu 2 is 4 times nu 0. So what is happening? Next, if the shortest wavelength of hydrogen atom in Lyman series is x, shortest wavelength in Lyman series, that means maximum energy. Shortest wavelength in Lyman series, that means maximum energy. Maximum energy in Lyman series. What is the transition? Maximum energy in Lyman series. What is the transition? Infinity to 1. Then longest wavelength in Passion series of helium plus. Longest wavelength, minimum frequency. That means 4 to 3. That means 4 to 3. So this asked is 4 to 3. That given is infinity to 1. So shortest wavelength of hydrogen atom in Lyman series is x. Then longest wavelength in Passion series of, remember, helium plus is asked. Right? How to do? Apply Rydberg equation. Apply Rydberg equation. What is the Rydberg equation? Nu bar is equal to 1 by lambda is equal to RH into 1 by N1 square minus 1 by N2 square into Z square. So for hydrogen, how much it comes? Nu bar is equal to 1 by x. X is given, lambda. R into, it is infinity to 1. Infinity to 1. So it is 1 by 1 square minus 1 by infinity square. You are getting R. So 1 by x is equal to R. Now go to helium. For helium, there will be Z square coming. Hydrogen only 1. Helium will be 2 square coming. So 1 by lambda is equal to Z square into R into, it is longest wavelength. So it will be from 4 to 3. So it is R into 1 by N1 square minus 1 by N2 square. You will get 7R by 36. 7R by 36. Now what is R? What is R? 1 by x. Isn't it? 7R by 36. That is 1 by lambda. We want lambda. Lambda will be 36 by 7R. Now 36 by 7R. 1 by R is equal to x. So it is 36x by 7. 36x by 7. Option B, the correct answer. Okay. Hope it is clear. Next. The increasing order of value E by M for electron, proton, neutron, alpha particle. Electron, proton, neutron, alpha particle. For neutron, charge is 0, mass is unit value. For alpha particle, charge is 2 plus, mass is 4. For proton, charge is 1, mass is 1. For electron, charge is 1 and the mass is 1 by 1840 times. 1 by 1840 times that of the proton. Or the unit mass, isn't it? It is 1 by 1840 times that of the unit mass. Now, just to compare, this is 0, this is half, 1 and 1840. In the order, it must be option D. Option D. Neutron, alpha, proton, electron. Neutron minimum, then alpha, then proton, then electron. E by M value is maximum for electron because the mass is negligible. See, when you know the electron is maximum, straight away these two options are cancelled. Then you have to compare between proton and alpha only. You need to compare between proton and alpha only. Alpha it is 2 by 4 half. Proton it is 1. That's enough to identify the answer. Next. Transition in hydrogen spectrum that would have the same wavelength as transition from n equal to 4 to n equal to 2 in helium. In helium 4 to 2. Helium atomic number 2. In helium 4 to 2. Hydrogen it will be 2 to 1. Hydrogen transition 2 to 1. You see, for hydrogen, it's a very simple shortcut. For hydrogen 2 to 1 transition. Therefore, helium plus transition will be 2 times of this. You multiply atomic number with this transition. So it will be 4 to 2 transition. Suppose the same transition you want to find for lithium. Suppose the same transition you want to find for lithium 2 plus. What you can do? The atomic number of lithium 3. Multiply this transition with 3. 3 into 2, 6 2. 3 into 1, 3. 6 3 transition will be similar to this. So to find the identical transition, you can compare with the hydrogen. The hydrogen one transition, the corresponding transition for the others will be into atomic number. That's a very simple idea to find out the answer. For a particular transition of hydrogen, the equivalent transition in other Bohr atom will be into atomic number. Okay. Next. Is option D. Option D. Next. De Broglie wavelength of electron that has been accelerated from rest through a potential difference 1 kilovolt is. You know the relation? You know the relation lambda is equal to h by 2 mev. Taught in the class. Lambda is equal to h by mv, and half mv square is equal to kinetic energy. You can apply that relation. Half mv square is equal to kinetic energy. Correlate the relation to get the equation lambda is equal to h by half mev. All data given. H known to you. Mass of electron you know, and the electron volt you know 1.6 into 10 power minus 19. It is given 1 kilovolt. So into 1000 you will be taken to the answer. Option B, 3.9 into 10 power minus 11. Right? Hope it is okay. Next question. Electrons are emitted with a zero velocity from a metal surface when exposed to a radiation of wavelength 6000 angstrom. The threshold frequency of the metal is zero velocity. Zero velocity means zero kinetic energy. Zero velocity means zero kinetic energy. That means h nu minus h nu 0 is equal to 0. That is h nu is equal to h nu 0. That is nu is equal to nu 0. That is equal to c by lambda. Right? So what is nu 0? C by lambda. What is C? You know what is lambda? Lambda given 6000 angstrom. Lambda given. Find out the frequency. Option B, 5 into 10 power 14. Again, simple calculation only. 6 3 there, 6 here. Simple calculation only. Okay, next question. Twenty-sixth question. Ionization energy of hydrogen is given, then ionization energy of helium plus is. Ionization energy means first orbit energy. So first orbit energy of hydrogen 1312 kilojoule per mole. What about helium? Into Z square. Into Z square. It will be simply into Z square. So ionization energy of helium plus will be ionization energy of hydrogen into Z square. So 1312 into 4. 1312 into 4, you get your answer. Next. See, ionization energy is nothing but E1. Ionization energy of hydrogen is equal to E1. Next question. The set of quantum numbers valence electron of beryllium. Valence electron of beryllium with atomic number 4, you know, it is 1s2, 2s2. This is 2s2. So n is equal to 2. N is equal to 2. L is equal to 0. Option D. N is equal to 2, L is equal to 0. Option D enough. So 2, 0, 0 plus half or minus half, it can be. Next. Number of unpaired electrons in ground state of carbon atom. Number of unpaired electrons in ground state of carbon atom. Carbon atom atomic number 6. It is 1s2, 2s2, 2p2. Number of unpaired electrons in p orbital. 2 unpaired electron. Option B. 2 unpaired electron. Next. These are the 2 unpaired electrons. 29. An electron moves with a speed of 6.6 into 10 power 4 meter per second within an accuracy of 0.01 percentage. The uncertainty in position of the electron is, so velocity given and the uncertainty given, and the uncertainty in position is asked. So delta x into m delta v is equal to h by 4 pi. Delta x into m delta v is equal to h by 4 pi. What is delta x? H by 4 pi m delta v. So what is h? Available. Delta v. Delta v is calculated here. This is the velocity and up to an accuracy of 0.01 percentage means 0.01 by 100. That is the accuracy limit. So it will be delta v will be velocity into the accuracy limit available. So it is 6.6 into 10 power 4 divided into 0.01 by 100. That is the delta V. And delta X, you just substitute H divided by 4 pi M delta V to get the answer. Again, not at all a tough calculation. You can easily work out to get the option A, 8.7 into 10 raised to minus 6 meters. Okay. Next. If the velocity of electron in the fourth orbit of hydrogen atom is v, then the velocity in the first orbit is, you know the relation for velocity. Velocity of Bohr orbit electron. You know the relation. And this is what the relation. Vn is equal to 2.19 into 10 raised to 6 Z by N. 2.19 into 10 raised to 6 Z by N. Right? In the velocity of electron in the fourth orbit is v. Then velocity of the first orbit is. So V4 is V1 into, this is V1. This is V1. V1 into 1 by 4. Hydrogen atom Z is equal to 1. So fourth orbit N equal to 4. V1 into 1 by 4. So what is V1? 4 times V4. Right? So first orbit energy when compared with the fourth orbit energy. First orbit energy when compared with the fourth orbit energy. You can see each orbit, not energy, velocity. The first orbit velocity compared with the subsequent orbit velocities. You can see first orbit if it is x, the second orbit will be x by 2, then x by 3, x by 4, because it is V1 into 1 by n. So it is coming V1 by n for hydrogen. So first orbit V1, second orbit V1 by 2, third orbit 1/3, fourth orbit 1/4, fifth orbit 1/5. So that knowledge, if there no need of any equation, you can straight away answer it is 4 times. Okay, and that seems to be the last question. And these are a few important questions from the chapter 2, structure of atom. Right? We will meet in another class with another set of good questions from another chapter. Okay, till then, bye, see you.